Now let's cover integrals of exponential functions. I think you're going to really appreciate that. Suppose I have the integral from e to the x dx. The integral is equal to e to the x plus c. Do you think you can remember this one? Suppose I have a function e to the u du. Then that integral is e to the u plus c. All right, just like differentiation, integration is very symmetrical and straightforward with exponential functions. So let's look at the function e to the 3x plus 1 dx. Now, suppose I let's let u equal 3x plus 1. Then du is 3 dx. So I need a 3 here and a 1/3. So this becomes 1/3 the integral of u du, which is 1/3 eu plus c. So this is 1/3, you put equal signs here, that's a good idea, of e to the 3x plus 1 plus c. Straightforward. Let's try another one. What do we have? The integral of 5x e to the minus x squared dx. You've got it. Let's let u equal whatever my argument of e is. That's usually a good place to start. Minus x squared dx. Then minus x squared. Then du is minus 2x dx. So I need a minus 2 here and a minus, whoops, my pen's not working, minus 2 here. So let me rewrite this as minus 5/2 the integral of e to the minus x squared times negative 2x dx. So this becomes minus 5/2 the integral of u du, or minus 5/2 e to the u du. So it's e to the u plus c. So it's minus 5/2 e to the minus x squared plus c. Straightforward. They really are. Compared to what I put you through, this should be a piece of cake. Now, what do I have something like this? E to the 1 over x divided by x squared. Again, whenever you have something to the exponent, start by letting u equal 1 over x. Let u equal that. Du is minus 1 over x squared dx. Okay, so if I have a negative sign here and a negative 1 here, this becomes negative 1 times the integral of e to the u times du. So this becomes, when I do this integration, it's negative 1 e to the u plus c. So it's negative 1 e to the 1 over x plus c. Confusing? I don't think so. I think this is pretty straightforward. Now, again, let u equal whatever your exponential function is. So, that's just the first thing to try. Let u equal e to the cosine of x, or e equal cosine of x. Then du, the derivative of cosine, is minus sine dx. So I need a negative sign here and a negative 1 out here. So this becomes negative 1 times the integral of e to the u du. So this is negative 1 e to the u plus c. So it's negative 1 e to the cosine of x plus c. Straightforward? Let's see. You give it a go. This is number 1, 2, and 3. When you're done, stop the video. When you're done, turn the video back on. We have a couple more things to do. Whoops, sorry about that. A couple more things to do. I like my arrows nice and dark. I know you don't care, but I do. All right. Now, What if we're trying to find areas bounded by exponential functions? Basically, what do we do when we have definite integrals? Same thing, folks. Let me let u equal negative x, du is negative dx. So I need a negative 1 here and a negative 1 on the outside. So this becomes negative 1 times the integral of e to the minus x dx minus dx from 0 to 1. I suppose I should put my limits in here. So this is negative 1 times the integral of e to the u du. Now when x is 0, u is 0. When x is 1, u is negative 1. So this becomes 0 to negative 1. Please don't let that mess you up. That's all right. So this is negative 1 times e to the u. I evaluate at 0 and negative 1. So this is negative 1 times e to the negative 1 minus e to the 0. So I'm going to distribute this negative sign through here. All right, and this becomes e to the 0 minus e to the negative 1, which is 1 minus 1 over e. And if I were to put this in my calculator, I would get this to be about 0.632. Now let's look at this one. The integral from 0 to 1 of e to the x divided by 1 plus e to the x. Let me let u equal 1 plus e to the x. Then du is e to the x dx. When x is 0, u is 1 plus e to the 0, or 2. When x is 1, u is 1 plus e to the first, or 1 plus e. All right, let's see what this gets us. So this becomes the integral from 2 to 1 plus e of, what in the world is it? E to the x dx is du. 1 plus e to the x is u. All right, so this becomes the natural log of the absolute value of u evaluated at 2, 1 plus e. So now I'm going to plug in what u is, and u is always positive, so I really didn't need those absolute value signs. It's the natural log of 1 plus e to the x. Well, let me just go and plug it in. Okay, I made a mistake, so I'm going to cross it out. So this is a natural log of 1 plus e minus the natural log of 2. Okay, if I were to put this in my calculator, I mean, you could simplify this as a natural log of 1 plus e divided by 2. And if you put it in your calculator, you should get about 0.620. Now let's try this one. Oh my gosh, let's just cry. This one's terrible. All right, this has got e's and cosines and e's and everything. All right, let's not panic. Let's let what is the integral of e to the u du? Let's let u equal e to the x. Du is e to the x dx. At x equal negative 1, u is e to the negative 1. At x equals 0, u is e to the 0, which is 1. So this becomes the integral from e to the negative 1 to 0 of, all right, e to the x dx is du. Cosine, cosine u to u. Now, When you have something ugly like this, that's the trick. Pick the argument as u and see if this works. If it hadn't worked, I would have done something else. So this is sine of u evaluated at e to the negative 1 and 0. So this is sine of, oh, why did I put 0? It's e to the negative 1. Guys, catch me on my mistakes. Negative 1 and 0. Oh, gosh. You mind if I recopy this? Because I want it neat. This is the integral from e to the minus 1 to 1 of cosine u du. So this is sine of u evaluated at e to the negative 1 and 1. All right? Do you see what I did? I made a mistake. So I'm actually going to leave this. I could redo this entire video, but I'm going to leave this to show you what to do when you mess up on the AP. Draw a single line through it, or double or triple, put a big X, it doesn't matter, and redo your whole problem, and then just continue doing what you're doing. So this becomes sine of 1 minus sine of e to the negative 1. And if I put this in my calculator, I get 0.482. Give this one a go. When you're done, stop the tape and finish your homework. Have a great evening.